Hello and welcome to my lesson. My name is Mr. Johnson. This is one of my 20-minute lessons, and today I'm going to be talking to you about nuclear energy, which is one of the topics for GCSE Physics Combined Science. And yeah, let's get to it. I'm going to share my screen with you now. So I'll pull this up so you can see what I'm talking about. And here we go. Okay, so nuclear energy. So what I want to hopefully get across to you by the end of this is that you understand the advantages and disadvantages of different types of nuclear reactions in generating electricity. This lesson is usually a precursor to the triple science and the lessons on fission and fusion and how they work. By the end of this lesson, you should be able to describe the difference between nuclear fission and fusion, and then describe the advantages of using nuclear reactions to generate electricity and the disadvantages of using nuclear reactions to generate electricity. So let's start. Redirective decay then. We've seen earlier in this unit that radioactive decay releases energy. Radioactive decay can involve the emission of alpha or beta particles at high speeds, meaning that they can carry kinetic energy away from the nucleus to make it stable. Gamma rays also transfer energy via electromagnetic radiation, again carrying it away from an unstable nucleus to make it stable. Other nuclear reactions then. Other types of nuclear reactions can also release energy. In some large unstable nuclei, the nucleus can be split into two smaller daughter nuclei. This process is called nuclear fission. Fission meaning to split. Another way is to take smaller nuclei and combine or fuse them under high temperature and pressure, and this produces larger nuclei and releases a large amount of energy in the process. Because I'm fusing them this particular way is called nuclear fusion. So, if we get a question about something like this, complete the sentence using one of the four endings below. Two types of nuclear reaction, a nuclear fusion, nuclear fission. They both combine hydrogen nuclei. Well, that's not true because we've already said, as a general rule, that fission splits a larger atom or a larger nuclei into two smaller ones, releasing energy, and fusion takes two and fuses them together, releasing energy. So fission doesn't combine, whereas fusion does, so they're not the same. Combine uranium nuclei. Again, this can't be true because we know that both reactions don't combine. Release neutrons. Well, at no point in our definition did we discuss the release of neutrons in fusion. In fact, in fusion we said that things are combining, not being released. So that again negates that one. And finally, D releases energy. Both these reactions release energy, that's why we do them. And so the answer is D. And that's our first task net. Describe the difference between nuclear fission and nuclear fusion. Next one, describe the advantages of using nuclear reactions to generate electricity. Here we go. Nuclear fuels store a lot more energy per kilogram than any other type of fuel. I mean, it's ridiculous the amount of energy that's stored in a kilogram mass of uranium in comparison to, say, a kilogram mass of coal or oil or gas. It's the term is energy dense. You might come across that term when talking about nuclear fuels in your particular syllabus, whichever one you're studying. But the more energy dense something is, the more energy is contained within a smaller mass. Nuclear fuels have a very high energy density. This means that they're very useful for things like naval ships and submarines, because if they have to be at sea for a very long time without the possibility to refuel, for example, in the application to the military where you've got a spy ship or a spy submarine where you don't want them coming up for a long period of time, then uranium makes sense as a fuel. They're also really useful for powering spacecraft such as satellites, because there's no possibility of ever refueling those if they're on a mission out to a far distant planet. So a nuclear engine or a nuclear reactor to provide energy to keep that operating is a very useful idea because it keeps the mass low, which makes it easier to get it into orbit. Nuclear fuels do not need to be burned in a combustion reaction, so they don't need an oxygen or air supply to allow them to release energy, which is again a really useful thing on something like a submarine because it doesn't have to keep coming up to replace the oxygen to allow the engine to produce energy. As they do not burn, they do not release carbon dioxide as a waste gas, which is one of the benefits to using nuclear fuels for the generation of electricity for, say, supplying it to the national grid in the UK. As it doesn't contribute carbon dioxide to the atmosphere, it cuts down the amount of climate change gases that we're producing. Using nuclear fuels does mean that we can use less fossil fuels. Again, this helps conserve those fossil fuels resources, because if we're using less of them, there's more of them left in the ground. We've got them for a longer period of time. So, conventional power stations that release energy from fossil fuels also produce pollutant gases such as carbon dioxide. Nuclear fuels don't, and the increasing amount of carbon dioxide from human activities in the atmosphere has been linked now to man-made climate change. In fact, it was only recently in the news that the UK government announced the commissioning of new nuclear power stations to relieve some of the energy mix from the old coal, oil and gas fired power stations. And this helps us to meet our climate targets and the amount of carbon dioxide that we're releasing in the atmosphere. Nuclear power stations then don't produce carbon dioxide, so won't contribute to climate change. As nuclear fuels are not burnt, they also don't release sulfur dioxide, which is present as an impurity in hydrocarbon fuels, and that then reduces our impact for acid rain emissions, or soot, which is a particulate that's found when burning, particularly coal, which can lead to complications like asthma or irritation of the airways in people living nearby. This is a really common question. Make a bullet list of the advantages of nuclear power generation. And do you know what? It's never even said make a bullet list. They normally say, for something like 6 marks, discuss the advantages and disadvantages of nuclear power. And I can tell you now, it's acceptable to write it as a bullet list, because as long as the answer's there, present and scientifically correct, a bullet list is just as effective as writing a whole list of pros. You can even make a comparison table with an advantage on one side, disadvantage on the other, and then list your points underneath, which sometimes helps because you can go from the advantage and or the other side, the disadvantage is usually the opposite or something to do with it. It helps you organize your task in a better way. But for this, I'd be looking at things like this. For the advantages, doesn't produce carbon dioxide when used to generate electricity. Straight away, really, really big advantage for our environment and climate change, especially given the current environment. 2, nuclear fuel is very high in energy per kilogram, or it's very high energy density compared to fossil fuels, meaning that we can use less of it and still get the same amount of energy out. 3, using nuclear fuels means there's less need to refuel over time. This is a very specific use, but it's really important for things like nuclear submarines or for nuclear-powered spacecraft. 4, using nuclear fuels conserves fossil fuel resources, which are finite. Now, as well as that, linked to that is the idea that to actually obtain fossil fuels, we have to mine and dig up the ground, which 1 leads to an eyesore, and 2 leads to habitat loss and destruction of woodlands and wherever the mine's situated, which in turn reduces biodiversity. So this prevents all of those things happening. So that's the advantages of using nuclear reactions to generate electricity. Now, if you are, quite like-minded, then you'll realize that once you know one side of the argument, the other side of the argument usually is the opposite or something linked to it. If we know the advantages, the disadvantages become pretty clear. But there are a couple of specific disadvantages to nuclear reactions to generate electricity that we do need to be aware of. So, first one, nuclear power stations produce radioactive waste that can last for thousands of years. And the waste is a big problem. I mean, just thinking about how to get rid of something that's ionizing for thousands of years, even millions of years, and then think about the problem of what can happen if that escapes, it makes for a big issue. This radioactive waste ionizing has to be stored very carefully and safely. The considerations for storing are that the containers for the waste are resistant to corrosion, so the waste cannot escape and mix with the water supply. So we can't just make them out of something like, steel barrels that can rust over time if left for a long period of time. Remember, these have got to be secure for thousands of years. We can't have water get into this waste, because if it does and the water absorbs some of that waste, it's then contaminated and then it can leach out into the soil or the surrounding area, which then gets into our food supply. So it has to be corrosion resistant. 2, the containers are stored in a geologically stable region. Wherever you store them, they have to be underground, but they have to be in a place where there's no earthquakes, no volcanic activity, so that there is no chance of them being cracked open by earth movements or by falling rubble in the event of an earthquake landing on the containers and cracking them open, again exposing them to the water supply. So they can't be disturbed. 3, that the waste is secured from people that may use it for terrorist acts, production of a dirty bomb or contamination of water supplies. So essentially, it can't just be buried underground and forgotten about. That particular area has to be monitored and has to be monitored securely to make sure that anyone who'd use it for nefarious purposes is also kept away from it. Nuclear power stations produce radioactive waste again for last for 10,000 years, or tens of thousands of years. In 1986, the reactor at the Chernobyl nuclear power plant in the Ukraine exploded. The material from the core spread up and into the atmosphere, and during that explosion, it just literally spread out in the upper atmosphere in the jet stream and the winds, and then fell to earth over the soil and water supplies with the rain that then fell. Some of that was spread out over a very large area by high winds in the very upper atmosphere, and all this caused increases in the incidences of cancers of the people who survived the explosion in the surrounding areas due to radiation exposure. People think that this risk makes nuclear power stations too unsafe to use, because even in the event that it's not an accident caused by a failure in the nuclear power station's regulatory mechanisms, but by an act of God, for example, in the Fukushima power station plant in Japan in 2008, which was hit by a tsunami, they just think we can't account for that kind of risk, and so it makes it too unsafe to use because it can spread so easily. So, bullet list of disadvantages now. We've got a couple of things to think about, but let's take a look. Provides or produces even radioactive waste that needs to be stored carefully. This is to prevent leaks into the environment so that it can't get into the water supply and then pass into the food chain. The risk of accidents like Chernobyl, where radioactive waste was spread out over a large area by an explosion that threw it up into the upper atmosphere where it was carried by high winds. The subsequent risk to human health of drinking or eating or breathing contaminated food, water, or air from the contaminated environment associated with these accidents like Chernobyl. In fact, one of the suggestions in the past for dealing with radioactive waste to try and overcome some of these obstacles was to load it onto a rocket and fire it up into space. As I'm sure you can probably imagine, the argument for this is what happens if the rocket explodes, because if it explodes up in the air with all that radioactive waste on it, there might not be any loss of life, but then it's exposed to the atmosphere and the wind currents there can carry that radioactive dust, which has just been made even smaller and even more, shall we say, duster by the explosion of the vehicle it was carried in. And that then was the reason for not using that as a method of disposing. So, this was a 6-mark question from my exam board. Everyone's exposed to background radiation. Some of this radiation comes from natural sources. There are many radioactive isotopes in nuclear waste. Technetium-99 is just one of these isotopes. People are worried about how we should deal with nuclear waste. Explain why it's difficult to deal with nuclear waste safely. There's a lot of stuff in that question that's not necessarily relevant, but the key idea here is people are worried about how we should deal with nuclear waste. Explain why it's difficult to deal with it. So how do we answer this? Well, if it was me personally, I would break down the answer in 3 parts. Usually 6-mark question, they're looking for 3 things, whether it's application of knowledge and then a link into something and then a link to something else. In this case, I'm looking at properties of nuclear waste, problems caused by it, and solutions to deal safely with it. So let's take a look. First off, properties. Radioactivity is dangerous because it's ionizing, and some isotopes have half-lives of thousands or millions of years. They can release alpha, beta, and or gamma radiation. These are the properties of radioactive waste. This leads to problems. Problems being that the radioactive waste or material can leak from containers if they're not sealed correctly. This then can lead to contamination of water supplies, which then can lead to crops from the soil absorbing that water and becoming contaminated themselves, which then leads into the food chain. This can lead to harm to humans and animals alike. And that comes from radiation poisoning or damage to the cells, to ionization of the cells, to damage to DNA. The waste also needs to be stored securely to prevent terrorism. So solutions to this: long-term storage in caves, underground, secure storage, or even under the sea, in containers that use radiation shielding, e.g. thick lead, thick concrete, and corrosion-resistant materials. And finally, this has to be in geologically stable regions, so there's no chance of an earthquake or volcanic eruption or some unforeseen earth movement or earth event causing those containers to be damaged and allowing that radioactive material to escape into the environment. And that is the end of my show, the end of my lesson. I'd like to say thank you for listening. I hope you've enjoyed it, and I will see you again in the future. Take care. Bye-bye.